But that's a human organism. And the question is, how can we keep that human organism functional in that particular contextual job? One way is to understand how their brain works. And if we can understand how the brain works on a variety of levels, we may be able to sidestep the proverbial hard question of the neurosciences. How does brain occur in mind? This is proverbial, realistically. If we have a large enough pattern repository of data and we can use those data, we can make maps. We don't necessarily have to know how it happens, we just have to know where. Because those maps are targetable, which then brings us to the next phase of brain-machine interfacing, which is interventional brain-machine interfacing. And these run the gamut, some things we can do peripherally that are donable and doffable that can hook up to our physiology somatically and therefore affect our nervous system bottom up. Things that are donable and doffable that we can put into headsets, helmets, wearables, semi-wearables, and ever more those things that are indwelling and that need not necessarily be a surgical implantation because state-of-the-art now is for next-generation non-surgical neuromodulation. Inhalables, ingestibles, deliverables via very, very small-scale units at the nanoscale that can then be segued to where they have to go in the brain and form literally vast arrays of sensors and transmitters to be able to real-time and remotely read from the living brain and write into the living brain. That sounds like sci-fi, doesn't it? It's not. This is a project at DARPA that I have the honor and privilege of working on called the N-Cube Project with my colleague Al Amandi.